like for you to give your full attention and a big round of applause for our very special guest speaker. This is Mr. Warren Dancer, and he is going to be talking to you about the wastewater treatment process.
Well, good morning. A better welcome would be, mine. Well, I want to thank Dr. Carter for having me. I was looking at some of your results on the nitrification, denitrification, and that's exactly kind of what we do in the wastewater treatment process. So we're going to go over that a little bit. I understand that you guys did some reading on wastewater treatment. Is that correct? Yeah. So you guys are going to be able to tell me all about it, right? Well, is this a talkative class or what? I mean,
they are.
Do they talk?
You can tease them too.
Oh, good. Because I love doing that. So what we're going to do to try to further understand wastewater treatment is we're going to try to do an analogy with the human body, and then we're going to try to relate it back to wastewater treatment, so hopefully we can understand that. So everybody had anatomy before? Yes. Okay, human anatomy? Yeah. Just checking, Okay, so David's going to help us with some stuff. So we're going to kind of go back to your grade school, and we're going to see how you are. So I might be picking on people, so if you get mad at me, just take it out on David, okay? So the first thing I want to talk about is your senses. How many senses do we have? Oh, wow. Oh, so we got a range from 5 to 6, so the average would be 5.5. So what are those senses? So just put an S up there. So we're going to talk about senses. How many? It's 5. So we got hearing, sight, taste. We're going to go back to taste in a minute. Okay. So all those, right? So we got hearing, seeing, touching, smelling, and tasting. So in wastewater treatment, we do all 4 of those. We don't taste. Okay, so we don't want to taste, so let's just kind of put that off the board. So then we're going to talk about air. So put an A up there. What is air?
Oxygen. A mixture.
Okay, it's a mixture of oxygen and nitrogen, hydrogen.
Gases.
There's a whole bunch of gases, right? so all of it. So anybody remember the percentages?
No.
Oh, come on, that's college class, right? Okay, so what? So nitrogen is about 78, what?
60, right?
Above 60. So we'll say somewhere around 78, close. What about oxygen? So now we only got 100%, right? So we already got 78. 10, 12, 7. Can we hit 20? 20. We got to have 20 to breathe. I mean, after when you start getting to 16, you start passing out. So you got to be above that. So let's say around 20, 21%. And then the other gases make up the difference, right? So we breathe mostly.
Nitrogen.
And you guys run that test too, right?
Yeah.
So that's the same test? Just curious, I didn't take science.
Is nitrogen the same as nitrate? That's what he's asking.
No. Oh, okay, good. No, right. So let's talk about matter. So what's the matter with me? So matter, how many states of matter is there?
3.
Most commonly, 3. You go into some of these advanced classes, they tell you there's 4 or 5. They start talking about plasmas and all this stuff. We ain't interested in all that. We're interested in the basic 3. So stop. When you was in grade school, when you did this, what did it mean?
Good number 1.
Yeah, the number. That's right. That's the number 1. So number 2.
Solid.
Oh, there we go. See, and number 3. Gases. And I know we're familiar with the gases because when I was out there, somebody let me know. All right. All right. I ain't gonna say who it was. Okay. So there's 3 things to matter. So now let's talk about some of the human systems. Human system. What's the human system?
What's one of your systems?
What's one of your systems? So quit messing with me.
What's a respiratory system?
There's a respiratory system. There's a digestive system. Come on, you got to give me one. Organ system. What's the organ system? Okay. Yeah, we got organs. Yeah. Okay. So digestive, respiratory, circulatory, right? musculoskeletal, all these different systems that we have there. So now when we talk about that, so in order for this human system and this human body to work, we got to eat, right? So what do we eat? Food, right? So now some people have different classifications of food. Some people are carnivores and herbivores, the vegans and all that stuff. We don't care about that. We just want food, right? Because what does food do for us? It gives us nutrients and energy, right? Right, so the same thing. So when we start talking about that bacteria has to have some sort of food too, right? Now, what do they eat? They eat nitrogen? No. What do they eat? Basic sugars, basic organics, right? Organics. So like when you had that plate last night, where'd you eat at last night? Tony Roma's, okay. So, that still exists, So on that plate she had ribs, right? So you had some meat and you had some bones. She gonna eat the bones? She's gonna toss the bones. She had a melon. So she eat the meat of the melon and throw the rind out, right? So the waitress I had some hair on my plate. So do you eat the hair? No, you turn it in and get a new plate. So if you just keep doing that, you have a bunch of friends, just take some hair with you. When you get all the way through, you put it out there. Okay, so so there's certain things that we do not eat, and the same thing goes with the bacteria. So then, let's talk about that. You did some testing and stuff, and you learned some things, right? So you learned how some of this bacteria converts some of the ammonia into nitrogen. I'm just curious, where did that nitrogen come from? From your body, right? That ammonia. So now this is what I believe, and this is what I was told by some professor that I was wrong. So I don't care. But so we breathe in more nitrogen than oxygen, right? And then when we excrete it through our number 1, it goes into the wastewater system as ammonia, and then those bugs, they eat some of that nutrients, the organic stuff from the number 2, and then that's their energy, their calories, and their job is to convert that ammonia into nitrites and nitrates. And then they can't breathe. We kind of we choke them, right? And we turn off the air supply to them. What happens? Do they stop breathing? They stop working. They die. No, what we do, or what they do, is nitrate is what? That's the chemical NO. So there's some oxygen available to them. So those pseudomonas, yeah, them guys. In order for them to breathe, they have to strip that oxygen off to breathe. And then what they do, what happens to nitrogen? Goes right back into there. So there's some kind of cyclic operation going on. And so I told the scientists that that's what happened. They said, Warren, that don't happen like that. And I said, well, that's what I'm going to tell everybody. So if you're talking to those high PhD doctors, don't mention that. But when you talk to me, let's talk like that, okay? All right, so then the other thing is once you guys get out of school, you're going to go out to these jobs and you're going to be interacting with other people, and you're going to learn some things. But I'm a kind of an environmentalist type person, so I believe that everything we do, we should not negatively affect the environment. So in order to do that, you're going to take this data and all this information that you have, you learn something, but then after you learn, you got to lead. You got to be able to stand up for the environment, because she don't talk much, but when she do, when Mother Nature speaks, ask those people in San Francisco, she just had a burp up there this morning with a 4.5. Yeah. Then those volcanoes, then the hurricanes. Yeah, she gets kind of pissed off, so I don't want to piss her off. So, but the other thing is that we use the environment to survive. If we can keep continuously contaminate the air that we breathe, that ratio of other gases and chemicals and particulates is going to get greater, and that's going to negatively affect us. And then we're going to end up sleeping 6 foot under dirt. Okay, so we got to lead, we got to protect. So what does that tell us? So that's the question. What is Warren doing here? So what we're going to do is we're going to talk about the wastewater treatment plant. So hopefully you understand it. So the body, the human body, and all these systems, that they work in a certain way. We intake food. The food that we don't want, we toss out, right? Then that food goes into our body, gives us energy, the calories to do things, to grow and reproduce, all that kind of stuff, right? So that food that goes in here, what happens here? It gets digested, right? And then we go into the number 1, number 2, and number 3. Sorry, I didn't mean to tell you, but the only thing I wanted to tell him is stay off that asparagus, man. It's a dead giveaway. Okay. So that's what we're going to talk about. So, and when you take that and you kind of compare that to a wastewater treatment plant, a wastewater treatment plant operates pretty much the same way. It takes in the food, right? Organics, right? And then it breaks it down through digestion, and then it comes out in 2 forms, 1, 2, and 3, right? It's going to come out as a liquid, a solids, and gases. Some of those gases are not very pleasant. Anybody been to a wastewater treatment plant other than you guys? Was it wonderful, the smell? Oh, you went to the wrong plant. At the plant I worked, it was graciously smelled good, and I mean, it just a good aroma. Okay, so we're going to do that. So as we go through some of these slides, we're going to kind of go back and refer to the human body. So anytime you get stuck on it, I ask you a question and you don't know, think about how it would happen in your human body. So just an example, if you had a bellyache, what would you do? Oh, you call in and skip class. No, we're not talking about that. So would you take something?
Yeah.
What would you take? Sprite. Wrong. Should be Dr. Pepper. But you might take an antacid or something like that. And that's what happens at a typical plant. If we get, if it gets out of balance, we'll add just a large dose of these antacids to do that. Okay, so here we go. Typical wastewater treatment process. So now,
What's the sort of board?
this is a smart board?
It is. If you touch it, it's going to fly.
Okay, so I'll point. So you see there's fine screens. Remember we talked about eating that plate of food? You kind of doing some pre-screenings when you sit down and look at that food. If you was over my ex-girlfriend's house and you looked at food, you just like, that's why I don't have her, So, but other things you look at, like the melons and the bones and stuff, you're not going to eat that, so you kind of, sometimes you cut it off the bone and put it off to the side. The corn on the cob, you toss in the trash, right? Well, when I was young, we didn't do that. We had other purposes for that. You know what that was? Yeah, somebody over 40. No, just messing with you. No, we had other purposes. So recycling is good. So then, now when you see it up there, primary clarifiers, not all plants have primary clarifiers. No, they really don't. And then you go into biological processes. All of them do have some sort of biological process. And then you go to secondary clarifiers. Then we talk about denitrification filters. And then we do disinfection. And it could be through ultraviolet light. It could be through chlorination or some other kind of chemical. Heat can also do it, but it just costs a lot. So basically, wastewater treatment is broken down into a couple of ways. So we have pre-treatment. Pre-treatment can occur at restaurants. You ever go to a restaurant and you go in the parking lot and you see like 3 little manholes out in the parking lot and it smells really bad? Well, that's part of the pre-treatment process, and that's where a lot of the greases that comes through from the system. So when they wash their dishes, the grease, it goes in there hot, and then when it cools off, it kind of emulsify and float, grease float. So it's trapped, there's baffles in there that keeps all the grease in there because we don't want the grease at the wastewater treatment process. Grease is another food source for the bacteria, a different type of bacteria that actually forms like a whole bunch of bubbles, and we'll see some of those in the slides there. So yeah, you Pre-treatment that occurs off-site. Primary treatment can occur by those primary clarifiers. And basically what that process does, it takes some of this material that's flushed down the toilet. You know, do you ever flush like your Barbie dolls or your G.I. Joes down there? Do you ever do that? Because we're looking for those people. Because they create a lot of work for us. You know, we get all these toys. And now, if you have money, go ahead and do that. We develop processes to capture that. So if you want to throw some 20s in there, that's tips. It's tips. You know, we accept tips. Do that. Okay, and then so that's the primary treatment. Then secondary treatment, and that's where what we're trying to do. We're trying to take that number one that's full of ammonia, and we want to convert it to nitrates and then nitrates, right? And then we want to get rid of, because nitrogen is what? What is nitrogen in the liquid form or solid form? What do we use nitrogen for?
The fertilizers.
It's a fertilizer. So just imagine if we have, 10 million gallons of water with a whole bunch of fertilizer going into a river, what's going to happen to that river? All the plant life. It's going to grow, right? All the plant life along the river is going to grow really, really fast. And then what do you think? The fish are going to die. And then when the fish die, they smell. And so it could be an ecological problem, right? Ecological. Okay, so we do that then. So this part here is a biological process. The secondary clarifier goes along with secondary treatment. And then you have filtration. We can have different ways of filtering. Anybody have a swimming pool? All these rich people, go ahead. Oh, girl, you go, girl. Yeah, you. I know you got a swimming pool. No. No, so the type of filters you have at your house or at these swimming pools were the sand filters, right? So you have sand filters, you could have cloth filters, you could have membrane filtration, you could have anthracite, coal, just all different types of media, diatomaceous earth. What was that?
What, diatomaceous earth?
You raise your hand?
Oh, no, I'm scratching my face.
Oh, okay, just okay, I'm just messing with you. Okay, so different type of filters for different purposes. The biggest thing about when we start talking about the STEM part of this is when you design a treatment plant, you always have the end result in mind before you design, because you want to design to have the water quality meet that standard at the end, right? So that's part of that. And then, of course, we talked about the different ways of disinfection. What is the most common one we use? Is it UV? It's chlorine. Okay, so some of the things we talked about with chlorine is they want to try to get rid of it because, I don't know if you remember PCBs. Anybody heard of PCBs? It's not good for you. Chlorine not good for you. Cause you lose your hair. Okay, so that was a joke. No. Okay, so let's talk about what happens at these treatment processes. Where does the water come from? Comes from homes. College, yeah, places like this. Then it's pumped to the treatment process. One of the things we try to use as much gravity as possible because we're trying to reduce the cost. So we have these pumping stations throughout the system. And then we go to these grit chambers and stuff. So on the board you can see the number 1 is you want to send the water. The water goes back to the rivers and streams. And the number 2, we got to get rid of it in landfills or so. Go ahead, advance. So in order to do that, we have to sample. We got to know what the recipe or the food coming in. We got to know the composition of the food, so we got to do some analysis. So we have Dr. Carter there sampling this stuff, and boo-boo. You can see all the... See, that's what we have here? Yeah, okay. Okay, so we collect the sample because we need to know what's coming in. Because pretty soon we need to know how well the plant is operating, so we're going to compare what comes in to what goes out. And then we do some math and make sure we get a good percentage of removal. So this is where we collect the money on these screens. When I first started, we had to do this manually. I had an old rake. Yeah, and there's a lot of number 2.
Oh, man.
Yeah, and some of them not only brown, there was some green ones too. Yeah, but you can see we made a lot of breakthrough technologically. We can actually pull out, corn and stuff like that. Corn doesn't digest very well, just in case you didn't.
What
But
about baby wipes?
baby wipes get trapped on here. I'll go to the next slide there. There's a close-up. And you can see some remnants of baby wipes and other stuff. You see a lot of corn on there? Can you see the corn, the yellow? Who had corn last night? Oh, you're ready? Yeah, good. You go ahead. It's okay. Raise your hand. So we're not going to punish you. We're just going to help us clean that off. Go ahead, next. And then, so, just like the bones and other material that we don't eat, the bacteria don't eat that, so we take it out. And that stink too, but anyway, so you get rid of all that the stuff that you don't eat. Next slide.
And does that go to the landfill, or where does that go?
That goes to the landfill. And then other parts of that is grit. Grit consists of, could be abrasive material, could be asphalt, sand, or other stuff that kind of in the street, when you're driving down the street, you see these circles in there, they have little pick holes in there that we use to get there, but also asphalt can actually get in there. So you could have coffee grounds, eggshells, and all the stuff that you put down the garbage disposal. How many have garbage disposals? I want you to just unplug them all, because we get the stuff down and I got to go down and clean it. But so we have people down there trying to, just really excited about trying to figure out what's in there. They're looking for gold. Well, I told them gold was in there, so they really said, let's get it. Get a pan.
That's
No.
Dr. Ortiz.
Yeah.
Elena Ortiz. That's Dr. Ortiz.
Yeah. So they just really excited about trying to figure out what's in there. Okay, next slide. Now the reason why we get rid of that grit, because that abrasive material, is because as we turn on our pumps are very close coupled. So if you have a bunch of sand, just imagine what happened to the metal material. It basically erode them, right? So we got to get rid of that stuff before we get down into the good process. The reason why we had that pre-treatment, remember I told you it creates that the grease float? Well, this is what happens. So this is a group of bacteria called Nocardia. Nocardia eats the lipids and the proteins that's in the grease, and then they proliferate and they grow really, really big. And sometimes if your pre-treatment system doesn't work, this whole basin will be covered with this foam, and then it'll overflow, and we come back to Phoenix College to get volunteers. Oh, thanks for volunteering. Yes, write that name down. Okay. And then other things you see, so when we don't get all that material out, it can get trapped on our piece of equipment. And so just imagine a whole bunch of clothing just hanging out. Anybody know what a clothesline is? Mm-hmm. Oh, I don't know. So we didn't have dryers when I was growing up. But yeah, we had to use the sun and these little clothesline. But it gets wet, it gets heavy. And so when that weight gets on, it could pull plugs out, it could add the extra weight, could restrict the flow through there, and just cause all kind of problems for us. So this is the first part of the biological process. And so this material, this water here is called mixed liquor. Don't drink it. Remember we don't taste, right?
Yeah.
So don't drink this. This liquor is not the kind you want to drink. And it's basically a combination of water that's returned, wastewater that's returned is full of bacteria, and the influent water that's coming in. So it's all mixed in there, so we call it mixed liquor. Okay. Next. So what you can see here is down here you add in air. You add in air. It's a process called aeration. So if you look at it, you can see that this is where we're going to begin to convert the ammonia into the nitrates and nitrites to nitrates, right? It occurs under aerobic conditions, and it takes about 6 to 8 hours for that process to happen. So other processes other than the oxidation ditch, you can have something called an SBR, which is a sequence batch reactor, and they basically take the wastewater and they keep it in one tank, and then they aerate it, turn it off. Aeration is kind of like a washing machine, and it goes on and off. Then they allow it to settle. The clear water comes to the top, the solids settle down to the bottom. Then they decant the clear water off, and then the process begins over. So it would take about 6 to 8 hours to do that. So different type of processes. So remember, under aeration, is where we convert ammonia into nitrites and then nitrates. Okay. The denitrification phase, remember, is we turn the air off. So what happens when we turn the air off, if we were to leave the air off, all the solids would settle down to the bottom. So we have mixers in there just to keep it in suspension, keep the bacteria in suspension with the food, right? So it can do their job. But remember, we've turned the air off, and so they're going to strip that oxygen off of that molecule. They're going to take that one to use for their respiratory system, right? And then the nitrogen is going to go right back into the air. Okay. That's called denitrification. Next one. Then here's the clarifier. Clarifier can act like not really a filter, but a separator. So the clarification, we slow the flow of the water down. So all this flock, this biological flock that was floating around in there, we slow it down, and then it begins to settle. So all the solids begin to settle to the bottom of the clarifier, and the clear water comes over the top. So as we put more water through the center, so all that brown water, that chocolate milk we had in there, would go in there, and then it comes out. And here's a diagram of a clarifier. So as the water would go in the center, it settled, the solids go down. You had these scrapers on the bottom, and the scrapers, they kind of channel the solids into a hopper that's in the center down there, and the solids go out one way, and the liquid goes out the other way. That kind of familiar?
And then more, so in the bottom, what settles out, is that where the bacteria settle to then?
Yes,
So it's like in your test tube, they kind of go to the bottom? Okay, so it's going to be the same thing here.
yeah, so it kind of settles, it goes down to the bottom with the food, and then some of it, go to the next slide, I think. Yeah, so some of the material that's going to float, some of the greases might get past the systems, and they float, and so we'll have scrapers on the top that actually directs them into the scum trough. Scum trough sends it back to the beginning of the process, and the water, there's a baffle that goes down, and the water comes underneath and over, leaving the scum and material on that side. Okay, and here's a picture, so all this nice clean water going out the side. Okay, so now let's talk a little bit about this is kind of where we begin to separate the process. So the water is going one direction, and the solids are going in another. So what we do with the solids we are full of that bacteria that settle down, right? So when we separate them out, they begin to get hungry. It sounds like a Texas accent, hungry. Yeah. Say hungry or hangry, but so what we do is because that bacteria is really, really hungry, we can send them back to the beginning of the plant. That's where all the food is coming in, right? So they get to munch, you know, and they eat all that food really, really quick before some of that other bacteria that we don't want, like the nocardia. We don't want the nocardia to get the food, so we send that bacteria back. And then it eats it and try to reduce the amount before it gets to that process. And then the WAS, because they didn't have an RSVP, we have to get rid of them. So basically, remember the first slide where we're sampling the beginning, and we want to know how much food is coming into the plant. And so when we find out how much food, so we want to give everybody, you know, a pound of food or an ounce of food. And so if we have 10 ounces of bacteria coming in, so how many bacteria strands do we get? 10, right? Okay, so when we're talking about the WAS, the WAS, that's the bacteria that did not have an RSVP. So basically, we've already measured the food, and we know how much we can support, so we send that amount of bacteria back to the process to eat the food. And then the RAS is basically the bacteria that we do not have enough food to support. Let's talk a little bit about filtration. At this particular plant, we have fiber filters that is going to remove a lot of the fine particles that actually pass through. Remember, we was talking about the clarifiers. We have the water going over and under the baffles. Well, sometimes that bring a little bit of fine particulate matter with it, and we have to filter it. There are several different kinds of filters out there. Just at this particular plant, they use the fiber filters. You could also use anthracite. You could use sand, diatomaceous earth. Some plants, membrane filtration plants, they actually have membranes that actually do the filtration. So after it's filtered, then you've gotten rid of most of the particulate matter in there, then you can go ahead and start with the disinfection. So we're going to get down into disinfection right now. This particular plant uses chlorine disinfection. Recently it changed from chlorine to actually chloramines, which is a combination of chlorine and ammonia. The reason why they switched because there was a disinfection byproduct of TTHMs, or total trihallomethanes, which is considered a carcinogen. So the chloramines actually last a little bit longer in the water, but they do not have they're not considered carcinogens. There are other disinfectants that are used. You could use, in addition to chlorine, you can use ozone to actually disinfect as well. So when you look at this particular slide, look down at the bottom, you can see how the trihalomethanes are formed. After the water has been disinfected, depending on your permit, it can go to receiving waters or it could go for reuse. So that's pretty much all it is with the water. And then now we're going to go back and look at the solids handling. A lot of plants have to get rid of the solids. They can get rid of it through at landfills. Some places may even try to inject it into the ground and use it as a fertilizer. This particular plant, and this is a photo of the 23rd Avenue centrifuge. So the wastewater, the solids go into the centrifuge, a chemical is added, and then it actually forms this material or biosolids, which is basically 20% solids and 80% water. So as you look at the material, you can see it looks a little bit kind of like rough pudding or dried pudding. But if you shake that container, it actually gives you that little jiggle. This material actually has a lot of power in it, potential power. We've sent some dried sludge out, had it measured, and it came out to about 5,500 to 7,500 BTUs per dry pound. So you can kind of see how it begins to dry on the top layer. One of the biggest problems with this is that most places have to pay by the pound or by the ton. And if you have 80% water in there, you're paying a lot of money. So depending on how you treat it, the biosolids will actually dictate what you can do with it. So you're going to find out how to do that by reading the EPA 503. And if you digest it, the sludge, you can do particular things with it. You might be able to use it on food crops and sometimes non-edible crops. Then other times, if it's untreated, you just have to get rid of it at a landfill. One of the things that we did at Surprise is we were trying to figure out how to save that money, because we were spending roughly, about $1,100 a day just on solids handling. So we came up with this idea of using solar panels to basically dry the solids or dehydrate them and get all that water, as much water out as possible. So we came up with this parabolic mirrors, and we can actually heat water up to close to 300 degrees, but we backed it down to about 250 and stored it. And then if you look at these panels off to the lower left, these square box or rectangular boxes, we actually run the temperature around 200 degrees. You remember that water boils at 212. And we were doing experiments for what was happening with outside, and then we had this greenhouse, and we was trying to see if there was a difference in the way the solid or the biosolids dried. At this point, we had inside the greenhouse, it was about, the humidity just rose pretty high, and outside, of course, in the ambient air, we didn't notice any difference. But in all cases, the material was able to dry and was able to get rid of the water, and we basically reversed that trend. We took out most of the water and got it to about 95 to 98% solids and only 3% water. So if you can do the math, you can see that we reduced the cost significantly. This is Warren Dancer. I'm a principal at ICT. Formerly worked for the City of Surprise and City of Peoria and Air Force. I'm signing out, so thank you very much for watching this film and hope you enjoyed it.